this here. So these are wrong. So, what we talked about yesterday is circles and circumference. We talked about the fact that the radius is the distance from the center of the circle to a point on the circle is considered our radius. The diameter, so this here would be our radius. The diameter is a line that connects 2 points on the circle and goes through the center. And we also know that the radius is equal to half of the diameter, or the diameter is equal to twice the radius. We also went over the fact that the circumference is 2 pi r, or we can say that the circumference is the diameter times pi, because we can use either form. And it's really just relating the fact that 2 times r, 2 times the radius is the same as the diameter. So it's just really changing radius for diameter or diameter for radius. We also know that the area of a circle is pi r squared. So if we know the radius of a circle, we can actually find its area. And we can go back and forth. Now, we've talked about circumference so far. We did a lot with circumference, area, diameter, but we actually didn't do anything with area. We talked about circumference, but we didn't do anything with area. So, the next part of the note sheets is actually the crop circles that y'all can see there. Now, the Circonian Martians finally arrive in the atmosphere of the mysterious new planet. They discovered that its gangly inhabitants call themselves Earthlings. The Circonians are suspicious of the Earthlings. Rather than making a grand entrance in an attempt at diplomacy, the Circonians leave behind a cryptic message in the form of crop circles all over the fields of this planet called Earth. They leave quickly, fully expecting the Earthlings to heed their stern demands. So, the crop circles left behind by the Martians are a code. They tell the Earthlings what the Circonians demand for them. The area of each circle in the diagram corresponds to a letter. So, what information do we need? Well, it would be good to know the either radius or diameter of each circle. So I'll give it to you guys here. So when we look at this here, the first circle has a radius of 6. The second one has a diameter of 6. The third one has a diameter of 8. The middle one has a radius of 15. The next one has a radius of 20. And the last one has a diameter of 10. So what we need to do is find the area of each one of these here to decode the message. And again, the area formula for this here, or any circle, is area is equal to pi r squared. So for any of these here, well, for a few of them, oh, that goes backwards. We already have the radius. And we could use that to calculate the area of each one of these circles. But we do need to find the radius of the others. So for the first one that has a diameter of 6 pi, its radius would be what? When the diameter is 8, the radius would be. And lastly, when the diameter is 10, the radius would be. So, when we look at each one of these here, so the first one that we have is radius is 6. So that would be what? 6 squared times pi. And 6 squared is pi. As we can see here, none of these actually are left in terms of pi. So if we round that, we would get what? 113. And which letter does that correspond to? D. Okay. Let's get, bless you. So the first spot is a D. And on the second page, you do have space. They gave you a whole page to actually work that out. So you can go on and write the letters there. I, on the other hand, do not have that space. I'm going to erase this here. And why don't y'all go on and work ahead and see if you can figure this out. Most likely you'll beat me to it. Because I'm switching between ink. Because the next one we can look at is when the radius is 3. Because we can say 3 squared times pi. Well, 3 squared is going to be 9 times pi. 9 pi is going to be 28.27, which approximately would be 28. And if I look at this here, that corresponds with, oh, and then we can look at the next one, which has a radius of 4. So we're saying 4 squared times pi. And 4 squared is 16 times pi will give us approximately 50.2, which rounds to 15, or 50, giving our next letter as N. Everybody getting about the same thing so far? All right. Now, if we look at the next one, we have an R of 15. So we have 15 squared times pi. 15 squared is going to give us 225 times pi will be 706.85. Now, if we look at all of our numbers, we don't have a 706, but this will round up to 707, which gives us the next letter as U. Erase all this here. And lastly, we have a radius of 5. So we're going to say 5 squared times pi. Well, 5 squared is. I skipped one?
The N is where you put the N where the U should be.
Ah, that makes more sense. I felt like there needed to be one more. See if it'll let me. No. So this should be U, and this should be N. And then I'm looking at this here, which should give us 79. And the one I missed is going to be what? T. So they requested donuts. The aliens demanded donuts. Funny because they're all about circles and donuts are circles. They're actually centric circles. Centric circles are two circles that share a common center. in different radiuses. But that's actually it for these here. Discard. So, lesson 12. What we're going to do next is we're going to look at some of the examples, and then you will have the exit ticket, and we are done for today. We can go on and start off with number 1. And with problem number 1, what is the circumference in inches of a circle with a radius of 8 inches? Well, circumference is equal to what? Now we notice that every single answer has pi in it, yes? So we're really looking at what? 2 times r. Well, the radius is what? 8. 2 times 8 is? Pi. That's it. Any questions on this here? We'll go on and look at this one here. The circle shown below has a diameter of 14 inches. Well, we said that the circumference, what is the circumference of the circle in inches? 2 pi r. But we also said circumference is equal to diameter times pi, yes? Well, if the diameter is 14, the circumference is going to be 14 pi. Those are kind of nice. Any questions on the first two? Okay. I think we're good. Those there. I want to look at number 4. Circles A, B, and C have radii with measures of x centimeters, 3x, and 6x respectively. What is the ratio of the radius of B to the diameter of C? So they told us we have 3 circles. Since they didn't give me any circles, I'm going to draw 3 circles. Now we know the radius of the first is x. The radius of the second one is, and the radius of the last one is 6x. So we have A, B, and C. Now it wanted us to compare the radius of circle B to the diameter of circle C. Well, what is the radius of B? 3x. Now the radius of C is 6x, yes? So what would its diameter be? Because the diameter is always twice the radius. So what we're comparing is 3x to 12x. Now both of these do have an x, yes? So we can simplify that out. Really, we're getting rid of the x. So we do have a common factor that we can simplify out. And if we divide each of these by 3, well, 3 divided by 3 is? 12 divided by 3 is? 4. So the answer would be 1 to 4. And really, if we wanted to say, look at the circumferences, compare the circumferences of these two here, we'd be doing almost the exact same thing. Well, try that again. Try that again. There we go. Because if I wanted to compare the circumference of B to the circumference of C, it would just be comparing our B's 2 pi r to C's 2 pi r. But in both of these formulas, what is the exact same? 2 pi, yes? So really, I'm just comparing the radius to the, and the radius of B is x compared to, which would be 1, 2, 2. Because when we compare circumference to circumference, it's really just comparing the units. If we're comparing area, well, area is always in units squared, so it's going to be whatever the proportion is squared. And volume would work the same, but instead of squared, it would actually be cubed. So, let's look at number 5. The circle shown in the figure below has a diameter of 12 meters. What is the area of the circle in square meters? Well, area is equal to what? Pi r squared. If the diameter is 12, what's the radius? 6 squared times pi. 6 squared is what? 36, yes? Well, apparently it's going to scroll. So the answer would be 36 pi. And that's it. Any questions on this here? I think we're good with finding the radius. Because if we know the circumference, we can divide it by. Well, actually, let's do this here. Circumference is 108 pi is what it told us. And how many inches is its radius? Well, circumference is equal to what? 2 pi r. Now, looking at this here, what do both of these have? They already have pi, yes? So if I'm going to solve for r, well, if they both have pi, I don't even need to focus on it. Because really, we're matching up with 108 to 2r. Well, to get r by itself, I need to divide both sides by. So really, we're looking at 108 divided by, which is? Any questions on this here? Okay. This one here is a little bit interesting. The circle that lies on the standard xy coordinate plane has its center at the point 8, -6. So that tells us that we have an x value of 8 and a y value of -6. So this here is the center. And passes through the origin. Well, the origin is our 0, 0. So that means 0, 0 is a point on the circle, and the radius is any distance from the center of the circle to a point on the circle. Well, what did we just make? A triangle, yes? Now the distance from here to here is how far? The distance from here to here is 6. Therefore, the distance to the center is, well, this here is actually a Pythagorean triple. Now, the one way we can look at it is the fact that c squared is equal to a squared plus b squared. Well, a and b are 6 and 8. And 6 squared is 36. 8 squared is, so c squared is equal to, square root of 100 is because I know I've said it in geometry, and I think I've said it in here. One of the most popular Pythagorean triple that they like to use, if you all remember what it is, 3, 4, 5. Well, what times, well, if I multiply 3 by 2, I get 6, 4 by 2 is 8, and 5 times 2 is 10. They really like to use 3, 4, 5. So really looking at this here, 6 and 8, and they're asking for the hypotenuse. Okay, it might be a multiple of 5. When they use triangles, they like 3, 4, 5. They also like 7, 24, 25 is another one that works out. So that tells us that the radius is 10. So to find the area, because that's what it's asking for, area is equal to pi r squared. Well, the radius is 10, and 10 squared is 10. And that's it. Questions on this here? All right. I want to look at, I didn't mean to create a new page. One more of these here. Where the heck is it? Here it is. Rectangle ABC shown below has side lengths of 8 inches, 10 inches, 8 inches and 10 inches. What is the area in square inches of the largest circle that can fit within the rectangle ABCD? So we're talking about it being inscribed into this figure. So if we put a circle in here, can the circle have a diameter greater than 10? Well, can the circle have a diameter of exactly 10? Because for either one of these here, with a rectangle or square, circle's diameter is always going to be, or kind of match up with the shortest length, because it's going to be restricted on one of them. So the diameter for this is 8. Area is equal to pi r squared. Well, if 8 is the diameter, the radius is 4 squared, and 4 squared is? So whenever we inscribe a circle into a square rectangle, it'll be whatever the shortest length is. And for a square, well, it's actually going to match up to be exactly what the side length is, because a square's side lengths are all the same. Any questions on any of this here? Any of the other problems that y'all thought were a little tricky that you'd want to see worked? All right.